Hello everyone, this is Karishma. Today I'm going to give you a video presentation on a sample of 400 items is taken from a population whose standard deviation is 10. The mean of the population is 40. Test whether the sample come from a population with a mean 38. Also calculate 95% confidence interval for the population. On this topic today I'm going to give a video presentation, and the course name is Probability and Statistics. Mm, this is my topic. A sample of 400 items is taken from a population whose standard deviation is 10. The mean of the sample is 40. Test whether the sample has come from a population with a mean 38. Also calculate 95% confidence interval for the population. Introduction. This presentation covers the hypothesis testing of a sample mean to determine if it comes from a population with a specific mean. We will also calculate the 95% confidence interval to estimate the population mean range with the high confidence. And the statistical methods are applied to a sample with 400 items and known population standard deviation. First one, hypothesis testing. Next, formulating null and alternative hypothesis. The null hypothesis H0 states that the population mean is 38. The alternative hypothesis H1 assumes the population mean differs from 38. These hypotheses provide the basis for statistical testing to confirm or reject if the sample mean of 40 could belong to this population. Calculating the test statistic Z-score. The test statistics is a Z-score calculated using the sample mean, population mean, sample size and population standard deviation 10. This Z-score helps determine the probability of observing the sample mean under the null hypothesis, informing acceptance or rejectance of HO based on standard significance levels. Interpreting results and decision making. The calculated Z-score is compared against critical values for the chosen significance level, typically 0.05 for a 95% confidence level. If the Z-score falls within the acceptance region, we fail to reject the null hypothesis, implying the sample mean is consistent with the population of 38, and otherwise we reject H0, indicating the sample mean differs significantly. This is the question, and the solution is given values or sample size. We assume that n 400, population standard deviation is equal to 10, and sample mean is equal to 40. Hypothesized mean is 38. Level of significance is 5%. Since the standard deviation is known and sample size is large, we must test. Step 1, hypothesis. Step 2, standard error. Step 3, test statistic. Step 4, critical value. Step 5, decision. And final one is called conclusion. Step 1, hypothesis. Population mean 38. H0 and population mean is not equal to 38 to failed test H1. Step 2, standard error. Standard error is equals to 10 by square root of 400. So standard error is 10 by 20, which means 0.5. Step 3 is test statistics. Z is equal to 40 minus 38 by 0.5, which means Z is equals to 4. Critical value at 5% level to failed, critical Z value is equal to 1.96. Decision. Step 5, calculated Z is equals to 4, which is greater than 1.96. Therefore reject H0. Conclusion, the population mean is significantly different from 38. 95% confident interval is 40 plus or minus 1.96 multiplied by 0.5, 40 plus or minus 0.98. So confidence interval is 39.02, 40.98. So we calculate the 95% confidence interval. So 95% confident interval is calculated using the formula sample mean plus or minus z population standard deviation by sample size, with a sample mean of 40, population standard deviation of 10, and sample size of 400. This interval quantifies the plausible range for the population mean with 95% certainty. Implications for population mean estimation. The confidence interval reflects the range where the population mean likely resides, guiding decisions and inferences confidently. A narrower interval implies more precise estimates. This helps assess if the hypothesized mean 38 is reasonable or if the population mean might be different based on sample evidence. Conclusion: the hypothesis test assesses whether the sample mean of 40 significantly differs from the population mean 38. Using the Z-test framework, the 95% confident interval further estimates the population mean range with high certainty. To get these tools enhance decision making about the population mean based on sample data and statistical rigor. Thank you.